So I wanted to capture this problem as a video because it is a pretty difficult problem. There's a lot of concepts going on here that we're going to have to pick apart and put together. So if at any moment something seems confusing, feel free to pause and rewind and do that as much as you want to really make sense of this problem. And that way you can, hear my wonderful voice over and over again. Or just make sense of the problem. Alright, so let's go ahead and begin by first starting with what it says to do is by solving algebraically. So we first start off with negative 4 sine 3x equals 2. And we treat this like normal. We do this the same way we've done every other type of equation before. We want to solve for our sine, our trig ratio. So we divide both sides by negative 4. And we get sine of 3x equals negative half when reduced. Remember that before, when we had a problem like this, what we would have to do is we'd have to say, okay, well, there's sine, it's equal to a negative ratio. We think of our unit circle, ASTC. And since our sign is negative, we will be in quadrants 3 and quadrants 4. So at this step, we should be really figuring out what is that actual angle. So now we say if we arc sine both sides, then we know that 3x, which is what we have here, is equal to, well, what is that angle when it gives us half? Well, that's going to be, in quadrant 3, that'll be 7 pi over 6. And likewise, when we are in quadrant 4, that will be 3x equal to 11 pi over 6. Now, normally we would say, okay, well, that's it. But the problem is now we have this 3 here. And we need to solve for this 3, get rid of that 3 so that x is actually by itself. By the way, make sure that you are copying all the notes so that I do see that you've watched the video, and that way you can actually claim your extra credit points. Okay, so watch the video in its entirety, make sure you copy everything down, and copy everything that I write down so I know when I look at your notes that you have indeed watched the video. Okay, so to keep on going, let's just solve for x. Now to do this, normally we would have just said, okay, well, let's leave it like that because it does say that our domain restriction goes from 0 to 2 pi. However, what I'm going to do is I'm actually going to add another 2 pi n, saying we can go around and around and around, finding its coterminal angles. Now, this is kind of counterintuitive to what we said earlier in terms of how really you don't need to add 2 pi n because its restriction is 0 to 2 pi. But we'll see why we have to add 2 pi n in just a minute. Okay, so basically now that we have this equation, we need to solve for x by itself. Now how do you get x by itself? Well, you need to divide everything by 3, or also that's the same thing as multiply everything by 1/3. So if you multiply the left side by 1/3, you also need to multiply this right side by 1/3. In doing so, we end up getting 6 times 1/3 is the same thing as 7 pi over 18. And for the 2 pi n times 1/3, what we end up getting is 2 pi over 3 n, like that. Okay, this equation, that's pretty complicated. We got fractions with unlike denominators. So what I'm going to do is actually make them common denominators so it's easier to solve. We see 18 is going to be our common denominator, so I'd have to multiply this entire thing by 6 over 6. So let's just go ahead and write that in. That's just going to be 12 over 18. Look at that. Magic. Alright, so let's do the same thing over to this equation. Okay, we need to get the x by itself, so we multiply it by 1/3, 1/3, and 1/3. So in the left side, we end up getting x, and on the right side, we have 11 pi over 18 plus 2 pi over 3n. Again, we have that 18. Again, we need to get common denominators, so again, we multiply by 6. So 12 over 18, like that. Alright, well now why did we do this? Why do we have the 2 pi n? Why are we adding this on both sides? Well, now let's just go ahead and find out what our solutions are. In our unit circle, we said that if you have 7 pi over 18, we have to add on the 12 pi over 18 n number of times. So, let me erase that actually. So, if n were 0, then basically we'd have the answer of x equals 7 pi over 18. If n were 1, saying now we're going to find that coterminal angle it's wrapping around, then we're going to get 7 pi over 18 plus 12 pi over 18. So that's going to give us 19 pi over 18. If we wrap around again, we say n is 2, then we get 24 pi over 18. 24 and 7 will give us our 31 pi over 18. How far are we going to go? Well, we know that our domain restriction goes from 0 to 2 pi. So if I think about 2 pi in terms of something over 18, then that's going to be 36 pi over 18. So if I try 3, I'm guessing it's going to be probably too much. 12 times 3 is going to give us 36, and 36 plus 7 is going to give us 43 pi over 18. And we see 43 pi over 18, that is exceeding 2 pi, so we can't have that as part of our answer set. So we end up getting these 3 answers here that actually work out in the interval from 0 to 2 pi, which is exactly why we have to add on that 2 pi n that we said earlier. If you just had the 7 pi over 6, then you would have just had that one answer right here over 18, and that wasn't enough. We could have gone another 2 times. Okay, so we can do the same thing over on the right side. When we solve for this, we say, well, n can be 0, so if n is 0, we'd end up just getting this 11 pi over 18. If n were 1, we'd have 12 pi over 18 plus 11 pi over 18. That's going to give us 23 pi over 18. As long as we don't exceed our 36 pi over 18, then we'll be safe. So if n is 2, we get 24 pi over 18 plus 11 pi over 18. That will give us 35 pi over 18. And look at that. Ooh, we just barely made it. So we know that we can stop there. Those are going to give us another 3 answers. Okay, so it looks like we have a total of 6 answers here. In our directions, it does say that we want to confirm our work graphically. So let's go ahead and do that. Now to confirm it graphically, our equation is basically actually a system of equations where y is negative 4 sine 3x, and also y is just plain old 2. Okay, so we're going to be graphing these 2 equations here. So let's go ahead and do that. Our equations were y equals negative 4 sine 3x and y equals 2. So we do have to recall how to graph transformations of trig equations. And when I look at this, what I remember is that the 3 is telling me that's 3 complete periods making up is the same as 1 normal period. And a normal period is 2 pi. So because of that, I'm going to go from 0 to 2 pi. And if I have 3 complete periods, basically what I'm going to see is a graph. I'm just going to draw a sketch here. It'll go 1, 2, 3 times in 1 normal period. So that's not really where it is because it's not shifted up at all. But what we're going to do is actually draw it in. Now to know where our periods are actually stopping each time, I know I have 3 complete periods. So I take my 2 pi and then divide it by 3. So 2 pi divided by 3, that's a third of it. 2 pi divided by 3 again, well 2 pi over 3, this will be 4 pi over 3, and then 6 pi over 3 is the same thing as 2 pi. So I just split this up into thirds. And now I know that my sine graph, it'll happen 1 time, 2 times, 3 times. What I also notice is that my amplitude, or the a value rather, is -4. So my sine graph actually gets reversed. So instead of going this way, I should be going in the reverse direction, like this. So there's 1 period, 2 periods, 3 periods. And I know that since the a value is -4, I'll have -4 here, and 4 at the top for the max and min. So I have 3 complete sine periods in 1 normal period of 2 pi. Okay. We also need to graph y equals 2. I'll do that in a different color. So if that's 4, then that must mean that this right here is 2. So if y equals 2, then we are finding when our sine graph intersects this y equals 2, this horizontal line. And notice it occurs at 1, 2, 3, 4, 5, 6 places. And look at how many answers we have. 1, 2, 3, 4, 5, 6. Magic. Okay, so basically if we were to correspond our solutions together, what we would see is 7 pi over 18. That would be this location here. 19 pi, well, if we work in order, 7 pi over 18, the next number would then be 11 pi over 18. 11 pi over 18 will be this. Let's differentiate them with different symbols. So these will be my triangles, and these will be my circles. Okay, so 7 pi over 18 reaches here. Its coterminal angle, when it happens again, is when that sine curve also repeats itself. So here we have that 1 time. Here's the second time. It's going to repeat itself right there. So that's also going to be the circle. This value must be my 19 pi over 18. And then the coterminal angle, when it does the same thing over again. So here we have 1 period, 2 periods. The third period, this is where it's going to repeat as well. And that's going to be my 31 pi over 18. Okay, so my triangles, I have 11 pi over 18. That's this one. This one must be my 23 pi over 18, and this one must be my 35 pi over 18. So here we see all 6 answers occurring in 1 normal period. And that's it. So make sure that you write everything that I have written down. And that's it.